Hi guys, today we're going to talk about alternating current motor, this one. So we're going to show you what is the type of the alternating current motor, and we're going to show you how they are working. Let's go.
Alternating current motor, also known as AC motor. What is AC motor? AC motor is the motor that converts the alternating current into the mechanical power by using an electromagnetic induction phenomenon. Is called an AC motor. This motor is driven by an alternating current. Next, the AC motor is mainly classified into two types. They are the synchronous motor and the induction motor. So guys, the synchronous motor is the motor that converts the alternating electrical power into mechanical power and is operated only at the synchronous speed. It's known as synchronous motor. The working principle of a synchronous motor is the supply is given to synchronous motor, a revolving field is set up. This field tries to drag the rotor with it, but could not do so because of rotor inertia. Hence, no starting torque is produced. Thus, inherently, synchronous motor is not a self-starting the motor. The next type of AC motor is induction motor. The induction motor is the machine which converts the alternating current electrical power into mechanical power by using an electromagnetic induction phenomenon. The induction motor is mainly classified into two types. The first one is the single-phase induction motor, and the second one is the three-phase induction motor. The working principle of an induction motor is, in an induction machine, the armature winding serves as both the armature winding and field winding. When the stator winding are connected to an AC supply, flux is produced in the gap. The flux rotates at a fixed speed called synchronous speed. This rotating flux induces voltages in the stator and rotor winding. If the rotor circuit is closed, the current flow to the rotor winding and react with the rotating flux, and a torque is produced. In the steady state, the rotor rotates at speed very close to synchronous speed.
So we are done. Go to alternating current motor or AC motor. So next we are going to go to show you what is brushless DC motor, also known as BLDC motor, this one. So we're going to show you how the detail is it. Let's go.
Brushless DC motor may be described as an electronically commuted motor which does not have brushes. This type of motors are highly efficient in producing a large amount of torque over a vast speed range. Basically, brushless DC motors, there are two types. The first one is outer rotor motor, and the second one is inner rotor motor. The basic difference between these two is only in the designing, but their working principles are the same. The basic principle of the brush DC motor and for the brushless DC motor are same. The brushless DC motor has only two basic parts, rotor and the stator. The rotor is the rotating part and has rotor magnet, whereas stator is the stationary part and contains stator winding. In brushless DC motor, permanent magnets are attached in the rotor and move the electromagnet to the stator. The high power transistors are used to activate electromagnet for the shaft to turn. The controller performs power distribution by using solid state circuit.
Hello, in my part I will explain about the application of AC motor and brush DC motors. See you.
For the next part is I would like to talk about the application of AC motors and brush DC motors. First of all, first example of AC motor is synchronous motors. In synchronous AC motors, the speed of rotor is proportional to the stator. As example, they both rotate in a synchronous fashion. These motors are known for their efficiency in maintaining the power of the overall system and can be used as stepper motors in some cases. Synchronous motors find their major applications in areas where accuracy is important. For instance, in clocks, timers, electromechanical robots, metering pumps, speed controllers and other industrial processes. Also, synchronous AC motors are specifically used in high precision drill machines and similar devices. Next examples of AC motors is an induction motors. Induction motors are the most common type of AC motors used in daily life processes, and their output rotation speed is proportional to the applied frequency of alternate current. Used in almost every process, induction motors are mainly used in water pumps, kitchen appliances, fans and air conditioners, automobiles and common industrial machinery like boiler pumps and compressors. AC induction motors are efficient and flexible, which allows them to match the load demand for almost any type of electrical application. Next is example of brush DC motors. First example is permanent magnet brush DC motors, which is the most common. These motors use permanent magnets to produce the stator field. They are generally used in applications needing fractional horsepower such as toys, radio control hobby applications, electric slot cars, appliances and more. It is more cost-effective to use permanent magnets than wound stators because they are cheaper to manufacture. The torque from a permanent magnet brush DC motor is limited by its stator field, which gives it good low-end torque and a limited high-end torque. The permanent magnet brush DC motor responds very quickly to change in voltage. This is due to its constant stator field, thus giving it good speed control capabilities. But they do have a drawback. Permanent magnet brush DC motors will lose their magnetic properties over time, thus degrading its stator field and causing the motor performance to decline. Next example of brush DC motors is shunt wound brush DC motors. These motors have the field coil in parallel with the rotor. The current in the field coil and in the rotor are independent of one another. Thus, the total current of the motor is equal to the sum of the shunt current and the rotor current. So, during normal operation, as the supplied voltage is increased, the total current of the motor will increase, causing the stator and rotor fields to increase. As total current increases, motor speed will increase, thus motor torque will decrease. However, once you put a load on the motor, the rotor current will increase, causing the rotor field to increase. If the rotor current increases, then the shunt current will decrease, causing the stator field to decrease. This will cause the motor speed to decrease, thus the motor torque will increase. Shunt wound brush DC motors have the performance characteristic of decreasing torque at high speeds and a high but more consistent torque at low speeds. The current in the field coil and in the rotor are independent of one another. Thus, the total current of the motor is equal to the sum of the shunt current and the rotor current. As a result, these motors have excellent speed control characteristics. Shunt wound brush DC motors are typically used in applications that require 5 or more HP, such as industrial and automotive applications.
As compared to the permanent magnet brush DC motors, shunt wound brush DC motors have no loss of magnetism and are more robust. Some drawbacks are that shunt wound brush DC motors are more expensive than permanent magnet brush DC motors and have the potential of motor runaway if the shunt current decreases to zero. This is very dangerous condition that can lead the motor to literally break apart.
Hi everyone, in my part I will explain about the comparison between AC motors and DC brushless motors. And the first one, we will go through the similarities between them. There are three similarities between both of them. The first one is both brushless DC and AC motors are both brushless and both run at synchronous speed. The second one, both of them have permanent magnet. The rotor magnets can be either ferrite or rare earth alloy such as neodymium. And the last one is both motors use an electronic mechanism to control current, which is they doesn't depend upon the mechanical system brushes to control current. There are four differences between AC motors and DC brushless motors. The first one is efficiency. The efficiency of a system is defined as the amount of output received as a percentage of what was input into the system. Therefore, when we talk about the energy efficiency of brushless DC motors, we are saying that we can obtain a relatively high amount of mechanical power in return for the electrical power that we use. The next one is the size. A brushless DC motor usually is smaller than an AC induction motor. Brushless DC motor is smaller because its body has less heat to dissipate, and BLDC motors use less raw material to build and are better for environment. The next one is high speed operation. Brushless DC system provide flat torque over a wide speed range, while AC motors often lose torque as speed increases. And the last one is difference in operation and performance. In BLDC motors, the stator coils are wound trapezoidally, and the back EMF produced has a trapezoidal waveform. Because of that, direct current is required in order to get the best performance from BLDC motors. While in AC motors are wound sinusoidally and produce a sinusoidal back EMF, so they require sinusoidal drive current in order to achieve the best performance. And the last difference is the type of drive current. The type of drive current also has an effect on the amount of noise that the motor produces. The trapezoidal drive current used BLDC motors tends to produce a greater amount of audible and electrical noise in comparison to sinusoidally driven synchronized AC motors. That's all from me. Thank you.